Let's summarize what we have studied today. Everything is going to be put in a table so that we understand, or we can easily know what we have done today. Now, to test for aqueous metal ions in few drops and excess sodium hydroxide, let's see the results we are going to get. For zinc, when a few drops of sodium hydroxide is added, white precipitate forms. When you add that in excess, it redissolves. For aluminium, the same happens. White precipitate forms in few drops, it redissolves in excess. For calcium, white precipitate forms. In excess, the precipitate stays. There is no change. So this summarizes our test for aqueous metal ions in few and excess drops of sodium hydroxide. Now let's see the second test. Zinc in few drops of ammonia will produce white precipitate. The precipitate will redissolve in excess ammonia. Aluminium will produce white precipitate in few drops of ammonia. There will be no change. The precipitate will stay when excess ammonia is added. So that is where we identify the difference between zinc and aluminium. The second test gives us our difference. For calcium, no precipitate is formed in both excess and few drops of ammonia. Now let's see the test for transition metals. Transition metals produce colored solutions they produce colored aqueous solutions. When they react with sodium hydroxide, the transition metal precipitates are formed. Okay, transition metal hydroxide precipitates are formed. So iron 2 will form a green precipitate, that is iron 2 hydroxide. Iron 3 will form an orange-brown precipitate, that is iron 3 hydroxide. And copper will form a blue precipitate, that is copper 2 hydroxide. So a blue precipitate will be formed. Now to test for ammonia, we are going to mix ammonia with ammonium. To test for ammonium ions, we are going to mix the ammonium salt with sodium hydroxide and heat gently. That will produce ammonia gas. Now, how do we know it's ammonia gas? It has this choking smell and then also turns red litmus blue. Okay, so red litmus is turned blue. And that is the test for these metal ions.